Okay, so we're going to continue talking about divisibility tests, this time about the divisibility theorem. So we just did one of these in the previous video, but I'm going to do one more. Is 1224 divisible by 6? Question mark. Okay. And what I'm thinking about is, can I do this, right? And I could definitely do this in doing some long division. This isn't a terrible mental math problem, just because this is broken down. You just have to see this, that I got a 1200 and I got 24. And I'm thinking about these. Each are going to be, this is 200, right, plus 6. No remainder. So I'll say 6 divides 1224. Okay, now here's what we're going to do. Is this, what we just did here, we can generalize in a bigger way. Okay, and this is what's called the divisibility, I think it's the lemma. Let's change the name of this. Divisibility lemma. Okay. All right, so suppose A is divisible by K and B is divisible by K. No. If B is, B is divisible, B is divisible by K if A plus B is divisible by K. Okay, sorry about that. All right, let me just say this one more time. Okay, so suppose I have some number A. So again, in your head, A and B are going to be fairly larger numbers. And I'm going to look at this really quick as well in a second. So if you want to think of A and B being these two numbers, great, and K is that. Put some concreteness in your head. So suppose A is divisible by K. Then the statement is B is divisible by K if and only if A plus B is divisible by K. Okay, so basically this, before I go on, this if and only if basically means that both directions are true. Okay? What that means is, so the first statement is just a fact. A is divisible by K. Right? It says, basically what we're saying is, if B is divisible by K, then the sum is divisible by K. But we also have the reverse direction, meaning if the sum is divisible by K, then B is divisible by K. All right. So let me look at that in this context over here. So I'm going to let A be 1200, B be 24. Okay. We know that 1200 is divisible by 6. Okay. So what we're going to use is, since b is divisible by 6, then a plus b equals 1224 is also divisible by 6. Okay. Okay, so one of the things about this is all of these lemmas, and when we do divisibility tests for this, they're basically all going to be these little lemmas too. I always think about these as they're shortcuts. Okay, so here's what we're doing is we're breaking down the problem into smaller pieces. So instead of doing 1224, what we're going to do is I'm going to pull off, I pulled off 1200 because I know that that is divisible by 6. And then all we have to do is check to see if 24 is divisible by 6. If it is, then the original is divisible by 6, and if it wasn't, then it wouldn't be. Okay, so that's what's going on. All right, let me show a little bit about this. I want to talk about a proof of these. Okay, we are going to be doing some proofs in this, and so it's a good idea to just start looking at the way that these work. We've got these two things, so picture proof of divisibility lemma. Okay. So here's what I'm going to do. So suppose A is divisible by K. All right. So this is a sort of, again, when we start doing this, I want to be able to do this for general, any number, whole number that this works for. So I need to show that A can divide up evenly into K rows. So I'm going to write it that way. Okay. So here's the idea with this. If B is divisible by 6, so that means I can take B, which I'm going to look at like a same picture. Okay, so just imagine that these guys can be broken up into the same K number of rows here. Right? Then all I have to do is mush it together, which you can kind of see, and you get that. Right? So this shows if B is divisible by 6, or by K, then A plus B. Okay, now this also shows, let me just put on a little extra here. Let's say, so remember A, it says A is divisible by K, so this picture doesn't change. Over here, I've got B is not going to be divisible by K, because there's going to be a little bit of extra stuff. So I break up into K rows however much I can, but I've got a little bit left over. Right? So if B is not divisible by K, then A plus B is not divisible by K. So that also is a nice little picture of that. All right. Okay. So that should give you a little bit of sense. All right. going to erase this because I want to do now the algebraic proof. And the big thing about the algebraic proof is this is like sort of the kind of the gold standard for mathematics. Picture proofs are really nice, but often, you know, among groups of mathematicians, it's like, nee, you need to do a little bit more. Okay. Okay. So our first thing is we're going to assume, right? So it says suppose A is divisible by K. So let's start with that. Suppose A is divisible by K. Okay. Then there exists an n such that A equals n times K. Okay. This was precisely just the definition of what we mean by divisible. All right. All right. Now, let's say the same thing. We want to show, and I'm going to have to do this in both directions. We're going to, if B is going to be divisible by K, we want to show that that's true. So, we're going to show what's often the forward direction, which we often use as just a right arrow to indicate this with a double thing. I'm not going to get into all the notation on this. So if B is divisible by K, then there exists I should say a whole number such that B equals M, let's call this M, times K. Okay. So this is all we mean for both divisible by K, A and B. If A and B are different, then we need different whole numbers. So I'm going to call one N, I'm going to call one M. Okay. Then A plus B is N times K plus M times K. Then we have one little step of algebra. I'm going to factor out a K. Okay, this is just the distributive law. But it shows it's a whole number times K. Which shows A plus B is divisible by K. All right. Good. All right, now the tricky little part is the other thing. The other direction is I'm going to assume that A plus B is divisible by K, and I want to show that B is divisible by K. So this is going to be the other direction, so the reverse. If A plus B is divisible by K, then A plus B is, I'm going to say, some Q times K for a whole number Q. And then how do I get b? I know what a plus b is as that. I know a, I've already assumed it up here, a is this. So b is a plus b minus a. So I'm going to say it's a plus b minus a. Kind of makes some sense if you just think about it, those all things cancel. A plus b we said is q times k. A is n times k, and we do exactly the same thing. I factor out a k, which shows b is divisible by k. All right, so I want to wrap this. Okay, so that goes the other direction, right? So that shows this. If this is true, then that's true. Okay, and some of these are really, I mean, this is like a really, really compact way of showing a lot of different things. All right, so let me just wrap this up. So the big thing about this is we've got this divisibility lemma, which I've written up here. Okay, we're going to use this throughout this, these next few videos. So make sure that you've got this jotted down and you've have some sense of it. Okay, we showed a picture proof of this thing. Hopefully that gives you some sense about how it works. This shows algebraically, I know this is big, but this shows algebraically that this is true. Okay, so, and the big thing about this is you're not going to have to memorize this. I'm not going to ask you to reproduce this, but it should give you some sense of what is it that we need to do. What are the steps that we need to do to go through and show things, right? And what we've done is we've started with the statement of the problem. A is divisible by k. And in this case, we've got two directions. If this is true, then this is true. That's what this was all about. And the if and only if the reverse says if this is true, then this is true. Okay. So that wraps up this video on the divisibility lemma.